Hello student, how are you? I hope everyone is fine. Today I lecture complex number because you know already already uploaded complex number into topics. So today I discuss some important type of questions, important types of identities, and these are very important for your exam purpose. So I give some identities and you note down this type of identities and it will help your exams. Okay. Now you already knows the identities of different types of complex numbers. So if I give z is equal to x plus iy, okay, x plus iy, and x is real part and y imaginary part. So that is, this is the Cartesian plane and Argand planes. You know everyone. This is x and y axis. This x axis is real axis, and this y axis is imaginary axis. Imaginary axis. And if I take x plus iy, this means this is lies in the first quadrant. And if given z is equal to minus x plus iy, this is also lies in the second quadrant minus plus. And this is Argand plane. If z is equal to minus x minus iy, that is minus x minus y, that is lies in the third quadrant. And z is equal to x plus x minus iy, x minus iy. So this lies in the fourth quadrant. So all our Argand plane have a real axis and imaginary axis, and same as concept of coordinate geometries. And you know that this angle is theta and this is pi minus theta, and this angle is theta minus pi, and this quadrant is minus theta. It is the rule of when changing the angle in according to the coordinate axis, according to the quadrant. So you apply this type of identities and you remember all of them, because you know everyone, first quadrant all are positive, and this is pi minus theta, this is theta minus pi, third quadrant, and fourth quadrant is minus theta. Okay. Now I move to next, conjugate. Conjugate means if z is equal to x plus iy, what is the conjugate of z? Conjugate of z means, and otherwise you can denote z bar, that is mean conjugate x minus iy. You changing the sign of iota. This is I, you can say this is iota. So x minus iy. Okay. And how can you find the modulus? Modulus means modulus of z is equal to real part square plus coefficient of imaginary part square, x square plus y square. Now some properties of conjugate complex number. Properties 1, z conjugate and whole conjugate is also z. Second, z plus z conjugate is equal to 2 times of real of z. Third, z minus z conjugate is equal to 2 by imaginary of z. Okay. No. 2 by not 2 by. This is 2 times, because 2 times of I. 2 times of I. Wait. 2 times of I. Two times of I, imaginary Im or z, and next is equal to this third and fourth. Z is equal to z conjugate. That means z is purely real. Okay, and next Z plus Z conjugate is equal to 0. That means Z is purely imaginary. Purely imaginary. Z plus Z conjugate is equal to 0. That is mean Z is purely imaginary. And next, noted. Okay, I move to next. This is 6. Z into Z conjugate is equal to, you can write a real of Z square minus plus imaginary of Z square. Okay, that is mean if I take Z equal to X plus IY and Z conjugate is equal to X minus IY. So if you product X minus IY, X plus IY, that is X square minus Y square. Okay, and imagine real Z square plus imaginary Z square. Z1, Z2 complex number. Now again, Z1 plus Z2 whole conjugate. You can write Z1 conjugate plus Z2 conjugate. Okay. Now, next, Z1 minus Z2 whole conjugate is Z1 conjugate minus Z2 conjugate. Understood? Okay. Now, practice regularly. If you do practice regularly, then you can write properly and you will do better understood. Okay. Now, next part, Z1, Z2 conjugate is equal to Z1 conjugate and Z2 conjugate. Okay. Now, next, Z1 by Z2 whole conjugate is equal to Z1 conjugate by Z2 conjugate. You can write individually if Z2 not equal to 0. Understood? And many students knows this type of identities, but it is very important for your exam purpose. Now, if P of Z is equal to A naught plus A1Z plus A2Z square plus so on N Z to the power N, where A0, A1, N, R and Z are complex number. So P of Z conjugate is equal to A naught conjugate, A1 conjugate, Z conjugate, A2 conjugate, Z conjugate square plus A conjugate N and Z conjugate N. This can be written as P dash Z conjugate. Okay. So P dash dash means conjugate of P of Z. A naught plus A naught N1, A1 conjugate Z, A2 conjugate Z, so on. Okay. So this is the some type of properties, and some question is also given in determinant form, and I given another part is if Z is equal to A1, A2, A3 and B1, B2, B3 and C1, C2, C3, find Z conjugate. Now you can write A1 conjugate, A2 conjugate, A3 conjugate, B1, B2, B3, C1, C2, C3. Okay. So this way you can apply the identities. Understood? Now A1, B1, C1 is equal if you write A1, B1, C1 are different types of different element. Now, properties of modulus. Properties of modulus. Okay. If Z is a complex number, Z is a complex number, then Z modulus of Z is equal to 0 implies Z is equal to 0. Second, modulus of Z is equal to modulus of Z conjugate is equal to minus of Z conjugate is equal to minus of Z conjugate modulus. Okay. Now third part, minus of Z modulus less than equal to a real of Z less than equal to modulus of Z. Now minus Z less than equal to imaginary Z less than equal to absolute modulus of Z. So this is the range. Okay, real Z lies between minus Z modulus less than equal to Z modulus. Okay, imaginary same. Now fifth part, Z and Z conjugate is equal to Z square, magnitude Z square. So now next part, Z1, Z2 is equal to Z1 conjugate, Z2 conjugate. Now Z1 by Z2 is equal to Z1 conjugate by Z2 conjugate. You can write, okay? No. Z1 by Z2 absolute value, that is modulus, is equal to individually you can write Z1 modulus by Z2 modulus. Understood? You note down first. If you have any problem, then please pause the videos and note down the identities. I move to next part. So next part is Z1 plus Z2 square, Z1 square, modulus of Z2 square, plus you can write Z1 conjugate into Z2 plus Z1 into Z2 conjugate plus, otherwise you can say Z1 modulus square, Z2 modulus square to real Z1 into Z1 conjugate, Z2 conjugate. Okay. Now next part. Z1 into Z2 square. Same way you can write Z1 square plus Z2 square minus Z1 conjugate Z2 minus Z2 conjugate Z1. Otherwise you can write two real Z1 Z2 conjugate. Okay. Next rule, Z1 plus Z2 square, Z1 minus Z2 square, absolute value modulus 2 times of Z1 square, Z2 square. Okay, 2 times of Z1 square plus Z2 square. Understood? Now I move to next part. If A and B are a real number and Z1, Z2 are two complex numbers, A Z1, B Z2 modulus square plus A Z1, B Z2 square is equal to A square plus B square, Z1 square plus Z2 square. Okay? So A Z1 plus B Z2 square plus A Z2 minus Z1 minus B Z2 square, A square plus B square into Z1 square plus Z2 square. Okay? Now, next part. Pause karo, pause. After pausing, you note down these identities. Okay, now next part. If Z1, Z2 not equal to 0, Z1 plus Z2 square, Z1 square plus Z2 square. This is equal to Z1 by Z2 is purely imaginary. Purely imaginary. Okay. Now triangle inequalities Z1 plus Z2 absolute value less than equal to Z1 absolute value mod and Z2 mod. Now next Z1 minus Z2 less than equal to Z1 plus Z2. Next Z1 minus Z2 less than equal to Z1 plus Z2. Okay. Next Z1 minus Z2 greater than equal to Z1 minus Z2. Okay. So this is the different types of identities. Now I explain another identities also. These are also important. Okay. And I already uploading complex number part 1. Uploaded the complex number part 1. Now on part 2 I release different types of identities. You watch the identities properly. Okay, then you can understood better. Okay, now next is square root logarithm of complex number. Square root logarithm of complex number. Z is equal to A plus IB. Then square root of Z. Then square root of Z. Square root of Z is equal to plus minus. This is the important identities. If you remember these identities, then it will easy for calculating the square root of complex number. A square plus B square under root plus A and whole under root. Okay, plus I into root half under root A square plus B square minus A whole under root if B greater than 0, B greater than 0. And another way, when B less than 0, so then half A square plus B square plus A minus I under root, same as previous. under root a square plus b square minus a. If b less than 0, then changing the sign of iota. Okay. Logarithm z, logarithm of a square plus b square, because if you take z is equal to a plus ib, I of tan inverse b by a. Okay. This is square root of identities. This is very important for exam purpose, because if I given x equal to 3 plus 4i, then you can calculate easy way, because half under root of 3 square plus 4 square plus 3 plus I under root of half into 3 square plus 4 square minus 3. This is the identities. And if I given 3 minus 4i, so that is b less than 0, b is minus 4. Then you can apply this here minus 1. Okay. So this is very easy technique. But you remember these identities, then it will be easy. Then it will be easy. Okay. Next. Z1 is equal to A plus IB. Z2 is equal to C plus ID. Then Z1 plus Z2. Then Z1 plus Z2. A plus IB plus C plus ID. A plus C, I into B plus D. Okay. Now next part, Z1 minus Z2. A plus IB minus C plus ID. A minus C, I into B minus D. Okay. So this, now third multiplication, Z1 into Z2. A plus IB minus C plus ID. Okay. A plus IB, and this is equal to AC minus BD plus I into BD plus BC. BD plus BC. Okay. So this is multiplication. Okay. Now I will discuss next class many identities with question. Okay. You note down the question and you practice. Then I will give every day new questions with your identities. Okay. Take care. Bye bye.